Okay, so it is time for chain rule. So chain rule happens when we have the composition of functions. So how I like to think about it is if we are eating peanut M&Ms. In order to eat a peanut M&M, you have to bite in the outer shell first, but everything on the inside stays the same. So if you eat a peanut M&M, you bite that candy-coated shell, but the chocolate and the peanuts stay the same. Then when we bite into the chocolate, the peanut's still intact. And then finally, we bite through the peanut, and then everything is kind of dealt with. So when I have chain rule, I am going to deal with my outside or outermost function first. And in doing that, I'm going to take the derivative of that outermost function, in this case, f prime. So f prime of, and we keep the inside the same, so g of x. Then we are going to multiply it by the derivative of the inside, g prime of x. I can keep doing this and keep kind of peeling back layer by layer by layer as I look at functions that have a little bit more. So what we're going to look at first is this right here. Our inside function happens to be this 3x squared. My outside function is this cosine. So if I want to take the derivative of this function, I need to take the derivative of cosine first. So the derivative of cosine is negative sine. We need something inside of sine, and that has to stay the same. That g of x, or 3x squared, stays the same. So I'm going to leave 3x squared inside of negative sine to kind of help us out. Now what we're going to do is multiply by the derivative of 3x squared. Derivative of 3x squared is 6x, so I get negative sine of 3x squared times 6x, which we could rewrite if we felt like it as negative 6x sine of 3x squared. Okay, this one's a little bit misleading sometimes. Our inside function is actually this sine of x, while our outside function is that cubed. The reason why is because I can rewrite this as sine of x cubed, and those mean the same thing. So that cubed is our outside function. So g prime of x is equal to, we're starting with that outermost function, that power of 3, so I'm going to use power rule. So to bring the 3 down, have the inside function stay the same of sine of x, and then take 1 away from our exponent, so our 3 becomes a 2. Then we're going to multiply this by the derivative of our inside, which in this case is sine, so we're going to multiply this by cosine of x. There's really not a lot that we can do to change this, so that's just kind of how we would leave it. Natural log of 4x squared minus 12. So thankfully parentheses makes it really easy to figure out what's the inside. So 4x squared minus 12 is our inside function. Natural log is our outside function. The derivative of natural log is 1 over x. So 1 divided by. X in this case is our inside function. So we have 4x squared minus 12. That's our denominator now. And we are going to multiply this by the derivative of the inside. So the derivative of the inside, we have 8x. When we do this, we can go ahead and multiply these two together. 8x is the same thing as 8x over 1, so I can multiply straight across to get 8x divided by 4x squared minus 12. E to the power of something is a very common thing to find. So our inside function is the innermost thing, which happens to be, in this case, our exponent. Our outermost function is the fact that we have an exponential at all. So if we take the derivative of e to a power, it is e to whatever power it was, and that's because we keep that inside function the same. So we have e to the 3x squared plus 14x, but we need to multiply it by the derivative of the inside, that 3x squared plus 14x. So we get 6x plus 14. I can move this kind of wherever I want, so I can have this in the front, 6x plus 14 times e to the 3x squared plus 14x, but it doesn't really matter. We have 4 times the quantity x cubed minus 5x squared to the 10th power. So when we're looking here, our inside function is everything inside of those parentheses. So everything in here is our inside function. Our outside function is this power. A lot of the times we can kind of incorporate that coefficient, or we can leave it alone. It just kind of depends on what we're feeling. So k prime of x. So if I start with my outside function power, well, we're going to do 4 times 10, so 40. And then we take 1 away from our power, the 9th power. Everything inside of our parentheses stayed the same, so I have x cubed minus 5x squared. We now need to multiply by the derivative of the inside. So the derivative of the inside, we have 3x squared minus 10x, and that is about all I can do unless I multiply everything out and rearrange it, but most of the time we don't need to. Our last one here is x plus 2 times the cosine of 5x squared all to the 4th power. So we can kind of deal with this in a couple different ways, but either way we have multiplication between an x and another thing that contains an x. So we have to use product rule. So let's start with what we need. So we do the derivative of the first part. So x plus 2's derivative would just be 1 times the original. So cosine to the 4th power of 5x squared. And we are going to add that to the derivative of cosine to the 4th of 5x squared times x plus 2. So I know x plus 2 has to be in here, so I'm just going to go ahead and write that. If we look at this, this one actually has a inner, outer, and a middle. So our inner function is that stuff inside of our parentheses, that x to the 5x to the 2nd power. Our outermost function is that 4th power. And we have a middle function, which in this case is that cosine. So we need to deal with the outermost function first, then the middlemost function, then the insidemost function. So we are going to multiply this by, we're doing the 4 first, so I have 4 times, the inside function stays the same, and we take away a power. So 4 cosine cubed of 5x squared. Now we're going to deal with the cosine of 5x squared, so cosine's derivative is negative sine of 5x squared. And we still need to multiply this by the derivative of 5x squared. So 10x. I could absolutely rewrite this. One of the things that could be nice is to take out things that are common, so pulling out a cosine to the 3rd power of 5x squared. If I did that, it would look like cosine of 5x squared plus, we have the x plus 2. We have 4 times 10, which would give us 40x. We also have this negative, so I'm going to go ahead and move this to a subtraction. So minus 40x sine 5x squared. And it's just kind of a lot, but this is absolutely something that could be asked of you. Chain rule kind of is plopped into everything because it makes a basic function more complicated. So we end up seeing chain rule a lot.